Hello friends, this video on combustion and flame part 1 is brought to you by examfear.com. No more fear from exam. Topics to be covered in this lesson are introduction, what is combustion, combustible and non-combustible substances, ignition temperature, fire control, types of combustion, flame, structure of a flame, fuels and efficiency. Concerns with burning of fossil fuels. Now, have you seen a candle burning or have you ever ignited a matchstick? You must have used the Bunsen burner in your chemistry laboratory to heat substances or chemicals inside the test tube. Your gas burner inside your kitchen, which is used for cooking a lot of things. When you try to burn a log of wood or charcoal or coal, so what happens when you burn these substances? What do you see? When a candle is burning, what do you see? We see the fire, right? So we see this flame of the candle. We can see that it is visible. Similarly, when the Bunsen burner is on, we can see the flame again. When you burn wood, you can actually see the fire which is being produced. The gas burner, when switched on, again, what do you see? You see the flames. Now, if you look at all of these flames and fires, they all look very different from each other. Do you think the flame of the candle and the flame out of your gas burner, both of them look similar? No, even their color is different, their appearance is different. So now in this lesson, we are going to discuss all about burning, how this phenomenon or how this process of burning takes place. Now what we call as burning in common terms is what is known as combustion in science. So in combustion, we will see what is this exact process, how does it produce fire, is it that all substances can give rise to fires and flames? So we are going to discuss all about that. So let us start with what is combustion. So it is a process in which a substance reacts with oxygen to release heat and light, and that is what we actually see as flame or fire in different substances. Now what happens when you light a candle? You see the fire, right? So because of that fire, if you try to light a candle in a dark room, what happens? When the candle is lit, the fire actually gives light to the entire room. So it actually releases light. And at the same time, if you try to take your finger near the flame of the candle, you feel hot. Why? Because heat is also released during the process of combustion. So you can think combustion as the process of burning, but how do we define this process scientifically? Because what exactly is happening inside that so much of heat and light is being produced? Now basically all that is happening is the substance is reacting with oxygen. Now this is very crucial. Combustion can take place only when oxygen is present in the surroundings. If there is no oxygen, there will be no combustion, there will be no burning. So this is basically combustion. Now when you talk about a release of heat and light, now it is not necessary that light has to be released during combustion of all the substances. Light may be released, light may not be released. Now if light is released, light can be released in the form of a flame, light can be released in the form of glow. For example, if you try to compare the process of combustion in a candle and coal, so here you see coal, and here you see candle. Now in both the cases, if you burn both of them, so what I am trying to explain is, if I burn both of these, the process that is taking place is combustion, because as soon as I burn it, the substance, that is the coal or the wax of the candle, it is reacting with the oxygen of the surroundings, and due to that reaction a lot of heat and a lot of light is being produced. Now if you compare these two scenarios, in this scenario you see, you really do not get a fire, or you really do not see a flame in case of coal. But what do you see? You can see a reddish glow on the coal. That happens due to combustion. Whereas in case of candle, you can very distinctly see the presence of this flame. Now, so it depends how light gets emitted in different substances. It depends from one substance to another. Now again, it is not also important that all substances will burn to release heat. So we can say that not all substances undergo combustion. You take example of matchstick. So do you think that the matchstick undergoes combustion? Yes, it does. Now, why I took this example was since I was talking about substances which do not undergo combustion, so that was just to confuse you. But yes, matchsticks undergo combustion, because you see, what do you actually need to do so that the matchstick catches fire? All you need to do is you have to rub it, or you have to strike it against the side of the matchbox. So when you strike it, there is friction. When there is friction, there is heat, and the matchstick ignites. Now once it ignites, you can see the flame. So light is released, heat is also released, and you can feel that if you take your finger near the matchstick, near the burning matchstick. So that way matchstick undergoes combustion. Now let us look at some examples of combustible substances. Now, what are combustible substances? Those substances which undergo combustion. That is, they burn easily to release heat and sometimes light. So just now I was telling you, right, that not all substances can undergo, or not all substances can burn to release heat. So those substances which can burn to release heat, they are called combustible substances, and examples are all these which you see on the screen. For example, paper. So if you see paper, do you think that paper burns easily? So just bring a matchstick near the paper and you see that immediately it catches fire. So paper is combustible. You take example of a matchstick. Again, it is combustible. It easily catches fire. You take example of diesel, petrol, kerosene. You take all these examples and you see that they very easily catch fire. That is why you would have seen that in the petrol pumps, people are not allowed to smoke. Why? Because the chances are very high that if in case somebody leaves a burning cigarette or a matchstick there, so the chances of petrol catching fire is very high. So that's why it is not allowed. You take examples of paints. You take example of magnesium or aluminium powder. Now most of the metals as such, like if you take example of iron or any metal as such, they are non-combustible. They do not undergo burn. They do not burn to release heat. But some metals in their powdered form, for example aluminium powder or magnesium powder, so all these powdered form of metals, they are combustible. That is, they get burned to release heat. So these are all examples of combustible substances. Of course, not to forget wood, coal, they are also combustible substance. Now it is just that all these combustible substances, they undergo the process of combustion in different ways. Some of them will produce huge fire, some of them will produce flames, some of them will just show some sort of glow. So that varies from substance to substance. On the other hand, we have a set of non-combustible substances which do not undergo combustion to release energy. So they will not get burned to release energy. Let us look at some examples. Most of the metals are non-combustible. So if you take a piece of iron, just take for an example, you take iron nail. So if you take this iron nail and put it, even if you put it on fire, do you see that the nail burns? Nothing happens to the nail. The nail doesn't readily burn, so it doesn't burn easily. So that is why it is non-combustible. Similarly, you take examples of glass. Glasses also do not burn. Take examples of say steel. So steel also contains a metal. So steel also doesn't burn. You take examples of stones, rocks. So they are all examples of non-combustible substances. You think of any of these substance and you will be able to find that they do not burn easily to release heat. So that is why they are categorized as non-combustible substances. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.